Hello all, welcome. Today my video will be about Yara language and how to write Yara rules, what is Yara, how can we use them, like the use cases and other stuff. I have decided for making this video after the poll that I put in the community section of this channel. So yeah, follow this section to decide for the next videos. So I also, like I said in my previous video, I'm also planning to do more Zeek videos because some people requested that too. I also want to share more about Zeek since I like it. So yeah, let's get started about Yara and the use cases and other stuff. So what is Yara? Yara actually is a language that you can write different search logic. Let's say you have a text file and you want to check them whether it matches some signatures or not. Like whether you are just writing a antivirus engine, like to search specific strings, to search specific conditions in a text file, or you are just trying to search some conditions in a like for let's say memory strings or in any strings for a binary. So lots of time like antivirus engines basically are like running with the logic similar to Yara signatures, like they are looking for files, binary files, but by checking with specific conditions, like if there is a specific string placed in a specific order, not just one. Like for example, if there is a URL, that URL is being placed at a specific byte, but another like signature, unique string, unit signature string is placed in another byte, and if these two conditions exist in same file, then this antivirus will trigger a signature hit saying that yeah, this belongs to this malware family. So with Yara you can define this kind of logics. Some commercial products are also using Yara for its own detection logic, not just antiviruses. Like Klamav is one of the examples of this Yara signatures to define signature rules. But also there are some network security solutions, network security monitoring solutions utilizing Yara to create some detections, because for example, if you give a mirror traffic to your appliance and if it is running Yara, then it can extract these transferred files in the network traffic and it can apply these Yara rules in the network traffic by reconstructing them, and it can find specific malicious files or specific data leakages. For example, if it's an internal to external traffic, it can look for specific zip transfers or bulk file transfers with some specific condition. Let's say if it see a confidential string in a document or internal use only string in a document, then it can trigger a leakage alert. Vice versa, like from external to internal traffic, like you can apply Yara signatures to your mail traffic so that you can find specific phishing campaigns, or you can just apply them to C2 traffics, like, or attacker traffics. Like, most of the time these kind of things are done by suricata rules or snort rules, like signatures in for network traffic. But if you have file reconstruction capability, then you can find more than uh, you can have more capabilities than snort or signatures. But yeah, like reconstructing the file is not so easy. So most of the time, like Yara is being used for files, for endpoint detections or endpoint scannings and other stuff. So yeah, there are lots of use cases. You can find them in the internet by looking vendors pages or by looking some communities. Um, but I know some commercial products applying these Yara rules for phishing campaigns to track phishing campaigns, and also there are some vendors like NSM vendors using Yara not just endpoint files but also network files by reconstructing them and using them. So let's start with a simple example, and this is a simple Yara rule. So from a top-down approach, I want to give this simple rule and then give more about this language, fundamentals of this Yara language. So this is a simple rule, and basically this meta section is giving a brief metadata about the this Yara rule, which is named malware, and it is looking like it is giving an description to it, like example and type is malware. Like you can define custom metadata, but yeah, this is just for like tracking purpose or just for indexing purpose. Like it is just metadata. Like you can add author information who wrote this Yara rule, or you can add licensing information. Like yeah, there are lots of opportunity here. But the critical part for a Yara rule is these sections, like strings and conditions. Like I said, Yara is a like advanced string searching engine, and it is running like you can run it on any file, like whether it's a binary or whether it's a just plain text file or whether it's a mail attachment. But you can create conditions like for this specific Yara rule, like it is looking for an MZ header, MZ string at the first starting from first byte, and also it is looking for a specific string without considering the case, like this no case statement saying that the case is not important. It can be a full uppercase or it can be full lowercase. So yeah, this string will be looking for all case conditions, and this MZ string is also let's delete this and let's make it more realistic, because MZ is being used for detecting executables and DLLs, like let's say Windows binaries, and let's search it in at first byte of the scanned file or to be scanned file, and also look this string in anywhere without considering case. So I created a test binary, like text file, to test my rule. So like I said, MZ is starting from first byte, and we have some random characters, and we have this test signature stuff, and we also have other random characters. Like you can add anything you want. So after downloading this Yara binary, like you can download it here. Here, virus total Yara. Basically, it's created by virus total, like now owned by Google. So you can download it here from the latest version, and after unarchiving it, extracting it, you will find two different binaries. So we will use Yara 64, and yeah, let's run it, this Yara rule in this file, and we will see a match, like malware rule hit in this file, because it matches with our condition, like first byte MZ and test signature, like this binary contains this test signature string in itself, and also some random character which is irrelevant in this case. But let's change something. Let's add another thing in beginning of this stuff, and now it won't match because, like I said, we will looking for this mz string at starting from first byte. So another thing, if we can delete this stuff and run it again, it won't match because we will look specifically to this test signature, whether it is uppercase or lowercase. Yeah, then it will match. So in its simplest form, like this is Yara, like we add a condition and we put an end condition, and it is looking for this condition and this condition, and you can add any condition as you want, and you can also have other statements like condition statements. Like for example, this is a specific condition, like searching a string at like starting from a specific byte, and also this thing. But you can also use other keywords. So for example, Yara also has this not keyword or contains keyword, ends with keyword. Like file size, you can also add file size. Like if you say like file size below let's say kilobytes. Oops. Let's make it, yeah, but if you make it this, yeah, it won't match because our file is just a simple file, like size is small. Yeah, so yeah, you can find example rules, and you can also write conditions just by using bytes, not strings. But it is not a good practice because your rules should be easy to understand, like as if you want writing a code, it should be easy to understand, it should be easy to share, because maybe we will just put it in GitHub and someone will use it and put some contributions and send a merge request. So yeah, they should be simple as much as possible. And yeah, you can also add some wide character strings, or you can also add ASCII characters conditions, like like we already mentioned about no case, so I won't be mentioning about it again. But this white keyword is another keyword, and it will look for characters encoded with 2 bytes. And if you write ASCII, and then it will look for ASCII codes, like not white strings but ASCII characters, which will be represented with 1 byte, as far as I know. And there is also XOR on the keywords, and you can also define base 64 strings. And for example, if you write base 64, it will look for different permutations, like for these 3 permutations. And yeah, you can another important thing, like you can also write regular expression conditions, so it will make your string search easier by writing this stuff. For example, if you are looking for a mail address that is changing for each campaign, that's changing for each sample, or any domain, because for example if attackers is placing a C2 domain in binary, but if it keeps changing, and if you are using this Yara rule to track this campaign or to track this actor, you can just write a regex and it can look for any domain, or it can look for any mail. So yeah, regex is also a good capability of Yara. So yeah, you can also take a look for all these keywords and other stuff. And also you can find lots of open source Yara rules in GitHub, especially for example this repo, and also some other vendors are publicly publishing their signatures in their GitHub repositories. Like, as far as I know, some vendors like Sentinel One or Cisco, even sometimes Mandiant, also sharing their Intel reports with their by adding their Yara rules and other stuff. Most of the time, vendors will have different standards while sharing them, but these conditions and strings will will work for you too. But for metadata, probably they will be using some custom fields. But yeah, if it compiles, if it can run, no problem. You can just copy them, use them. But please make sure that you are like complying with the licensing, because for some Yara rules has strict licensing conditions. You cannot use them in your commercial products or other purposes. So yeah, please be careful about these licensing issues. So yeah, TLDR, like today we'll learned about Yara language, how to use it, what are the use cases, what are the basic syntax. So you can just try to download a malicious file and try to write a Yara rule using that to detect that. But make sure they are using a safe environment. Do not try to write Yara rules while like Yara rules for malicious file while you are in your host machine. Use as isolated environment to not infect yourself. And there are also some tools that can that can help you writing Yara rules automatically. Like YaraGen is one of these tools, like to help generating Yara rules. Like you are just giving some files and some conditions, and it is helping you, because if you are using Yara in production environments, like false positives are big concerns, and also false negatives are like big concerns, because you will have lots of legitimate files and you wouldn't want to see a false positive match for some legit binaries, because if you have 1000 machines or 100,000 machines, and you will see lots of matches, even for one false positive file match, you will see them hundreds of matches. So yeah, make sure that you are testing your rules with legit binaries too, because yeah, you will see that yeah, my Yara rule is catching the malicious one, but you will also need to make sure that you are not hitting the legitimate files while trying to catch the bad files. That is, there is a trade-off, like every detection rule. So yeah, you can also take a look to this project called YaraGen, and make sure you are testing your rules and other stuff, and also use the open source community, use open source rules, and yeah, thanks for listening to me. So if you have any more suggestions for next video, write them in the comments, or if you like the video, if you enjoy the video, do not forget to like it. in the down section of this video. So yeah, thanks for listening to me. See you in next video. Take care.